Hi there, and welcome to Machine Learning Without Math. Today we're going to take you through a crash course in machine learning, taking you from knowing almost nothing about it to a very simple machine learning model built on a relatively straightforward data set. So let's get started. What is machine learning? Well, machine learning means just that, teaching a computer to learn something from data. Today, we're going to walk you through exactly how that works. We're going to use some common machine learning tools. We're going to use Python. We're going to use a distribution of Python called Anaconda, and the two packages that we're going to use today are called scikit, learn, and pandas. Those are very, very common, often used in data science shops. They're also all entirely free, so you can download these and get started on your own very, very easily. We're also going to use a data set that we'll make available to download. Very simple data set, nice and straightforward. There is a little bit of data pre-processing required, but I've never faced a machine learning problem where there isn't. So there we go. So I want to get into a little bit of the background of machine learning, some of the types of machine learning first. So we'll talk through those. But first off, I want to talk a little bit about hands. Now, let's imagine that we wanted a computer to recognize pictures of hands. There's a couple of ways we could do that. The first way is that we could build manual rules to describe what a hand might look like. Or we could allow the computer to learn for itself. Now, let's think about what type of manual rules we want to build if we wanted to describe exactly this hand. We could start off by identifying the fact that there are 4 fingers and they're all pointing upwards. We could say that there is a thumb that sticks out to, in this case, the left-hand side. And then we could take a look at the palm and say, look, it's a large flat area that sits in the middle of the hand. That's all well and good, but if the hand were, for example, to turn upside down, then our fingers would be pointing down, the thumb would be coming out the right-hand side, and the palm would no longer be quite the same shape that it is at the moment. So instead of doing that, why not take many, many, many hands and show the computer all of these pictures of hands and then allow it to learn and infer what a hand looks like to a computer instead of having us manually try and build an exhaustive set of rules for a process. Now, you might think that sounds simple for a hand, and it probably is, because hands have a fairly limited set of features that allow us to recognize them. It's pretty unique. But there are many, many other things where the rules that we would have to build are so complex and so time-consuming that the only practical way to do it is to allow the computer to figure out what the rules are for itself. And that's where machine learning comes in. There's 3 types of machine learning. We're going to do some supervised machine learning today. You could also do unsupervised learning, or we could talk about reinforcement learning. We'll talk a little about what each of these mean. So supervised learning means that we're going to give the computer some data and we're going to tell it what it is, and we're going to allow it, by learning from what is in the data, to figure out what the outcome is. So in this case, what that really means is we're going to show it some pictures of hands or some hands, and then we're going to show it some things that aren't hands, tell it which are which, and allow it to then learn from that to figure out whether a new picture that we show it is of a hand or whether it's not of a hand. This obviously requires labeled data, so we have to have some data, in this case, hands and not hands, that we know what the outcome is, and we can tell the computer what the outcome is. This allows the computer, as I said, to learn from the data so that when we show it a new object or a new picture, it can tell us whether or not that picture or that object is a hand or anything else that we choose to do it. Now, because we can make this prediction, this is often called predictive modeling. It's not supervised and predictive modeling, not quite synonymous, but they're often very close. One is used to generate the other. The second type of machine learning is unsupervised learning. In this case, we're not going to tell it whether the pictures are of hands, but we're going to allow it to come up with some common features within the hands. So we're going to show it lots and lots of pictures of hands and then say, these are all the same thing. What sort of features do you see? What things are common amongst all of these items? We could also use it to divide up items. So we could say, here are lots of pictures of hands. Divide these into groups for me. And maybe the computer would come up with groups like hands that are palm up, hands that are palm down, hands that have a thumb coming out one side, hands that have a thumb coming out of the other side, so a left hand and a right hand, things like that. We don't need labeled data for this. You can use any type of data. And it's often called data mining or descriptive modeling. So when you hear people talk about data mining, what that means is they're often using data to come up with a better understanding of a particular category rather than to make a prediction. Third and final type of machine learning that I wanted to introduce to you guys today is called reinforcement learning. In this case, this is for games, so it requires a set of steps or a set of moves, and then when we know the outcome, for example, whether you won the game or you lost the game, we give the computer a reward or a punishment based on whether it was right or wrong. In using our hand analogy, this would be, we say to a computer, I want you to draw a picture of a hand, and if it draws a picture that looks like a hand, we give it a treat, a reward, and if it draws something that looks completely unlike a hand, we'll give it a punishment. Now, obviously, starting off randomly, this is not a great solution for understanding what a hand looks like, because unless we give it some sense to start with, it's going to take a very long time for it to figure out exactly, if it ever does, it's going to take a long time to figure out what a hand looks like for this type of problem. But if we have a game like tic-tac-toe or chess or checkers, this can help the computer understand a series of moves that led to a particular outcome. The final thing I want to introduce before we get to the Python code is how the code is structured. So this is a very basic machine learning process, and you'll find that this is quite common across most machine learning processes. There's 4 steps. The first one is sort of administrative. Obviously, we need to import all of our needed packages and data. Within Python, it's good to keep these all stacked up in one place at the beginning of the code. That way, if there are any dependencies or anything else that needs to be installed, we'll talk about what that means in a second, you can see it right there at the top of the code. The second step, and often the longest step, is data pre-processing. This means cleaning up the data, making sure that it is all valid, making sure that the data is in the right format for what we want to do, making sure that we have numbers, we don't have letters, all sorts of things like that. There's a number of ways you can do that. In fact, there's more than a number of ways you can do that. There's almost endless ways you can do that. But the ultimate goal is to process the data into something that is nice and neat and tidy, and that will fit into our next step, which is to train the model. Training the model means that we're feeding our predictive model the data. We're allowing it to make those inferences to understand what's going on within the data and to predict an outcome. And then the final step is some sort of model evaluation. So we always want to know how good our model was. And we're going to do that, as you'll see as we get into the data, by splitting our data into 2 parts, a training set, which we're going to use to train the model, and then a testing set, which we're going to use to test the model so that we know how well the model works on new data that it hasn't seen before. So with that, why don't we jump into the code? So let's take a look at this Python script, shall we? And as you can see, we have the sections labeled that we just talked about in the presentation. First thing we're going to do is we're going to import all of the packages and data that we need in order to run our model. So there's 2 parts to this. The first part is importing packages. These are pieces of Python code that we can import and use in our code without having to have all of the source information in there. It's one of the things that makes Python such a flexible platform for machine learning and for predictive modeling. In this case, we're importing the 2 packages that we talked about in the beginning. The first one is pandas. That's going to give us all our data sets and data frames. And then we're going to import scikit learn, and we're actually going to import several individual pieces of the scikit learn package instead of importing the the whole thing all at once. The next thing that we're going to do is we're going to import our data. Now this data set is a bunch of information about the prices of cars. So why don't we take a look at the first 5 rows and we'll see what we're dealing with here. So you can see that we have a number of a whole bunch of variables that gives us information about a car, and then finally getting to this price number. And what we're going to do is we're going to build a linear regression model that allows us to predict what the price of a car is based on all of the variables that we see over here. Now, the first thing that we're going to have to do, obviously, is a bit of pre-processing. All of the variables that go into our model need to be numeric. So these ones where it says fuel type and we have gas and body style as a convertible, that's great information for me as a human being, but I need to convert it into something the computer can understand. So the very first thing we're going to do is we're going to remove some of the columns that we know we don't want, so we're not going to bother converting them. These don't have any good information about the car itself. In the case of the make, there's just too many individual categories for us to be able to practically convert it into something the model can accept. So we're going to go ahead and get rid of those. And then you can see that once we've got rid of those, the data frame itself is a bit smaller. The next thing we're going to do is we're going to take all of these individual columns and we're going to convert them to numeric columns. So we're going to start with the number of cylinders, and we're going to do it a few different ways. There's a number of different ways we could do this. The first one is we're going to convert anything that has words for a number, like the number of cylinders, where we have like 4, 6, 5. We're going to convert those to an actual number. We're also going to create binary variables. That is a 1 or a 0, depending on whether something is true or false. And then we're going to create what's called dummy variables for some of our categories. This means that we take the dummy variable, we take the categorical variable, and then we take each category that that variable has, and then we create a binary column for that category. So up here, instead of saying convertible, we'd have a column that was called convertible, and we'd have a 1 or a 0 in it. You can think of that as a question. So we're saying, is it a convertible? And if it's a 1, yes it is. If it's a 0, no it's not. So we go through a number of steps in this process to convert all of these datas to numeric. And here we're going to create our first dummy variable. And you'll see when we create our first dummy variable, then we're saying, is the style convertible? Yes, it is. And then no, no, no. Is the style a hatchback? No, no, yes, no, no, and so on and so on and so on. Then we're going to do the same for the drive wheels. And then finally, since we created new columns as we converted each of these pieces of data, we're going to drop all of the old columns. So these are the ones with the words in it that we don't want. Now that we've got rid of those, we can do one other thing with our data. And again, this is part of the pre-processing steps. And this is dealing with any missing values in the data. So we have some rows with missing values in them. You can see here we have NAN for bore and stroke. We have NAN for horsepower down here. And we need to get rid of those because we can't have a null input into our model. So we need to find a way to replace them. Now, there's an almost endless way of methods, or an endless number of methods that you could use to replace null values. What we're going to do is a common one, which means we're just going to take the average of that column. So we're going to take the average bore and the average stroke, and that's what we're going to put in for this NAN value. It's what we're going to replace it with. And then we're going to do the same with the horsepower column and with the peak RPM column. We're just going to take the average of those, put that in there. That gives us an estimate of what that variable might be. And you can see after we've done that, when we run our function again to see where there are NAs in the data, they are all cleaned up. And the final part of pre-processing, as we talked about, is this training and testing split. So we're going to take, we're actually going to do two things in this section. We're going to split our data into the data that we're going to use to predict and the target. So right here in this line, data X is all of our independent variables. What does that mean? That means that's all the data that we're going to use to make a prediction. Data Y, that's our dependent variable. So that is the variable that we're trying to predict. In this case, it's the price column, and data X is everything except the price column. And then finally, as I said, we're going to split this into a training and a test data set. We do that because we want to test our model on unseen data, that is, data that we didn't use to build the model, to really test how good it is. It's a really important part of machine learning, and it's what allows us to build models that generalize well to data that they haven't seen before. And we do that to prevent overfitting. So what is overfitting and why do we want to try and prevent it? Well, I want to go back to our hand example. So let's imagine again that we were building our model of a hand and that we had a computer that had correctly identified that these were fingers and that all hands had fingers. Now, that's a good thing, right? We know that all hands have fingers and that you can generalize that quite well. So you could say that, if you see things like this, they are fingers. But what if it found other features that didn't make as much sense? So you can see that on this particular hand, the fingernail is quite long on the thumb. That's very specific, and it's probably something unique to this hand. It's not something that we're going to see across all hands, and that's going to allow us to identify whether something's a hand or whether it's some other body part. Or what if it looked at the gap between the thumb and the index finger, or found something very specific in the creases across the palm or across the angle of the wrist? Those are things that are very unique to this particular hand, to this particular data set, that don't generalize well. And that's why we use a training set and a test set. The training set allows us to train the model on data, and the test set allows us to see how well it generalizes to cases that it hasn't seen before. So we don't have issues where we use very specific pieces of information from the training data set in order to try and make judgments about new data. So now that we've got all of our data sorted out, we've got our training and test sets split up, let's go ahead and build our model. Now, I picked the linear regression model for us to use here because it's quite a simple model and doesn't have many parameters for us to tune. There are many, many different models within the scikit-learn package, and you can pick any one of these if you wanted to use it, and they basically all function in a very, very similar way. It's one of the things that makes that package so handy. All we do is we initialize the model, and then we fit it against our data. So I'm just going to go ahead and do that. And now that we have our model, you see it was very fast to train. It's another advantage of linear regression models. We can go ahead and create some predictions so that we can try and understand how well our model works on unseen data. So again, this time I'm predicting based on the test set. And we're going to look at some fit statistics. Now, there's a little bit of math in here, but we'll try and keep it as simple as possible. The first fit statistic that we're going to look at is called the R-squared score. This is a number between 0 and 1 that is the amount of variance in the dependent variable that is found or that we can identify using the independent variables. That means this is how much the price changes based on all the data that we have in our model. Now, it's not going to be 100% because there's some things that influence price that maybe we don't have in our model, but it's pretty good. And as I said, it's a number between 0 and 1, and you can often express it as a percentage. So we could say that about 72% of the change in price is explained by all of the variables in our model, and that's pretty good. Next, we're going to look at the mean absolute error and the median absolute error. And you can see I just printed those out right here. The mean absolute error is the average amount that we missed by, that our model missed the prediction by. Obviously, it's not going to be spot on for everything. And on average, we missed by $2,591.16 when it came to predicting the price. Again, that's actually pretty close. The median absolute error is similar to the mean absolute error, but this means that half of our errors are smaller than the median absolute error, and half of our errors are larger than the median absolute error. And the reason it's different from the mean is because the mean is impacted by maybe we had one or two predictions that were just way off. Maybe there was a Ferrari in the data set and we missed the prediction on price by $100,000. The mean takes that big miss into account, and that big miss counts for more in the mean than the median. In the median, we just stack all our errors from largest to smallest, and then we look halfway down the list, and that's where we get the median from. So that's why the median is different from the mean. And again, we're only missing by about $2,000, which I think is a pretty good model, considering we only used a very simple model type, and we didn't actually train it on that much data. So let's maybe take a look at what this model could be used for. Now we've got this model, and now I've trained this model on my data. Let's say that I'm shopping for a new car, and I want to find out whether this car is priced fairly based on the data that we give it. Based on the data that we've used, that we've found, that we've gathered, and the model that we've built, is this new car a reasonable price, or should I shop around for a better car and a better deal? So I went ahead and I put in all the information for this new car that I'm considering. You can see it there. It's just filled out as if each of these were a column in the data frame. And then we're going to go ahead. First of all, we're going to make a prediction, and then it's going to print out the result, which is the fair price for the new car is $39,488.93. So now I can go out and I can look at whether that's the price of the car and whether it's above or below that, and I can decide how much I should pay. And with that, that is our very first machine learning model. Thanks for watching. If you enjoyed the video, if you thought it was helpful, then go ahead and give us a like, hit that subscribe button, and I hope that we will see you guys again soon.